Some engines fail quietly. Others refuse to fail at all, even after the companies that built them disappear. In heavy industry, that kind of survival creates an uncomfortable contradiction. This series explores engines engineered with such discipline, margin, and foresight that they continued running through mergers, bankruptcies, labor strikes, and executive collapse. These were not lucky designs. They were machines that earned trust in war, infrastructure, and continuous service, while corporate decisions around them unraveled. As balance sheets weakened and boardrooms emptied, the engines remained, forcing operators, governments, and entire industries to choose between replacement and preservation. What emerges is not a celebration of nostalgia, but a conflict between mechanical reality and institutional failure. Because when a company dies, but its engines keep working, the question is no longer about design, it is about responsibility. Built to last, sold to die. The engine that survived corporate collapse. The Fairbanks Morse opposed piston diesel was never supposed to outlive the company that built it. Designed in the 1930s and refined through World War II, the engine, most famously the 38D818, was engineered for submarines, locomotives, power plants, and remote industrial use. It was complex, unconventional, and brutally durable. What followed was a paradox that would define its history. The engine proved nearly indestructible, while the corporate structure around it steadily unraveled. Fairbanks Morse entered the mid-20th century as a diversified industrial giant, producing everything from scales to turbines. The opposed piston diesel was one of its most technically ambitious products. With 2 pistons per cylinder, no cylinder heads, and a compact power-to-weight ratio, it delivered efficiency and endurance that conventional diesels struggled to match. In naval service, the engine earned a reputation for surviving conditions that destroyed other power plants. That reputation, however, did not translate into corporate stability. By the 1950s, Fairbanks Morse was under financial pressure from multiple fronts. Competition intensified, margins tightened, and management struggled to prioritize product lines. The opposed piston diesel required specialized manufacturing, precise assembly, and a skilled support network. It was expensive to build and difficult to scale for mass commercial markets. While customers valued its reliability, executives increasingly viewed it as a burden rather than a strategic anchor. Conflict emerged internally. Engineering teams argued for continued investment, pointing to long service life, military contracts, and industrial demand. Financial leadership countered that the engine tied up capital and offered limited growth compared to simpler, cheaper diesels flooding the market. The dispute was not about performance, it was about control. The engine worked too well in niches the company no longer wanted to serve. As Fairbanks Morse restructured in the 1960s, divisions were sold off, merged, or abandoned. The diesel business became fragmented. Rights, tooling, and responsibilities shifted between owners, creating confusion for customers and service providers. At times, support depended less on official channels than on former engineers and third-party specialists keeping the engines alive in the field. The collapse was not sudden, but it was decisive. By the late 1970s, Fairbanks Morse no longer existed as the integrated industrial force that had built the engine. What remained were fragments, licenses, spin-offs, and successor firms with varying degrees of commitment to the design. The company failed to capitalize on one of the most resilient engines ever put into service. Not because the engine underperformed, but because it did not fit evolving corporate priorities. Controversy followed the breakup. Operators accused successive owners of neglecting part support while continuing to profit from service contracts. Military and industrial customers were forced to navigate shifting suppliers, inconsistent documentation, and uneven quality control. In some cases, newly manufactured components failed sooner than original wartime parts, raising questions about whether cost-cutting had compromised standards. Yet the engines themselves refused to disappear. Submarine engines ran decades beyond expected service life. Stationary units in power plants continued operating with minimal intervention. Locomotive applications, though limited, demonstrated the same pattern. Once installed and properly maintained, the engines endured. The conflict between mechanical reality and corporate failure became impossible to ignore. What made the situation more striking was that no competitor had fully replaced the opposed piston design in its original roles. Even as Fairbanks Morse vanished, the engine's core advantages, compactness, efficiency, and survivability, remained relevant. Engineers revisiting the design decades later found little to criticize in its fundamentals. The problem had never been the engine, it had been ownership. The engine's survival created an uncomfortable narrative. Customers trusted a machine whose manufacturer no longer existed. Service networks were sustained by necessity, not corporate vision. Knowledge was preserved informally, passed between technicians and operators rather than managed through official channels. The engine became an orphaned asset, kept alive by demand rather than direction. This disconnect exposed a broader truth about industrial collapse. Companies fail for reasons engines cannot fix: misaligned incentives, strategic drift, and financial decisions that undervalue long-term performance. The Fairbanks Morse opposed piston diesel became evidence of that failure. It was built to endure war, neglect, and extreme operating conditions, but it could not survive executive indecision. In the end, the engine did not save the company. The company failed to save the engine's place within it. What remained was a machine that continued running long after boardrooms emptied. Factories closed, and logos disappeared. Not because it was celebrated, but because it was too well built to stop. Engineering excellence inside a financial train wreck. Some engines fail because they are poorly designed. Others fail because the companies behind them collapse first. The latter category is far rarer and far more revealing. Few examples illustrate this better than the Sulzer RTA, low-speed marine diesel engines produced during the turbulent final decades of Sulzer Brothers as an independent industrial power. These engines became benchmarks of reliability and efficiency, even as the company that engineered them unraveled financially and strategically. By the 1970s, Sulzer was already under pressure. Once a Swiss engineering titan with interests spanning locomotives, turbines, compressors, and marine propulsion, the company faced rising costs, global competition, and internal fragmentation. Management struggled to balance legacy manufacturing culture with the capital demands of modern engine development. Amid this instability, Sulzer's engine division delivered one of its greatest achievements, the RTA series of two-stroke marine diesels. Technically, the RTA engines were exceptional. Designed for large ocean-going vessels, they delivered high thermal efficiency, long service intervals, and predictable performance under continuous load. Ship operators valued them for fuel economy and mechanical longevity at a time when fuel costs and downtime increasingly dictated profitability. In engine rooms around the world, RTA units built reputations for running tens of thousands of hours with minimal internal wear. That excellence, however, masked deep internal conflict. Developing the RTA series required sustained investment in testing, metallurgy, and precision manufacturing. Engineers pushed for tighter tolerances, improved scavenging systems, and conservative operating margins. Financial leadership, facing shrinking returns in other divisions, viewed the engine program as capital-intensive and slow to monetize. The engine was profitable, but not fast enough, not scalable enough, and not aligned with broader corporate restructuring plans. By the early 1980s, Sulzer was no longer a unified enterprise. Divisions competed internally for resources. Profitable units subsidized struggling ones. Strategic focus blurred. The engine business, despite its technical success, became entangled in debates about divestment and licensing. Management questioned whether owning manufacturing made sense when competitors were shifting toward modular production and global partnerships. The result was a series of controversial decisions. Sulzer licensed core engine designs to external manufacturers while reducing its own direct involvement. Support responsibilities became fragmented. Customers purchasing Sulzer-designed engines increasingly dealt with third-party builders, each interpreting standards differently. While the designs remained sound, execution quality varied and accountability blurred. Internally, engineers warned of long-term consequences. They argued that the engine's reputation depended not just on drawings, but on manufacturing discipline and service continuity. Those warnings were noted, but overridden. Financial urgency took precedence over engineering cohesion. The engine survived. The corporate structure did not. By the late 1980s and early 1990s, Sulzer dismantled much of its original industrial identity. Assets were sold, divisions spun off, and the engine business effectively separated from the organization that had created it. What remained of Sulzer bore little resemblance to the company that had designed the RTA engines. Yet the engines continued operating across global fleets, largely unaffected by the corporate collapse behind them. This created a strange contradiction. Ship owners trusted engines whose original manufacturer no longer existed in any meaningful form. Technical documentation remained valid, but institutional knowledge dissipated. Maintenance expertise shifted from corporate channels to independent specialists, former engineers, and operator-driven networks. The engine's reliability reduced urgency, but also concealed the long-term risks of fractured support. Controversy followed quietly. Some operators reported inconsistencies in replacement parts, quality across licensed manufacturers. Others noted that later production runs lacked the over-engineering of early units. Disputes emerged over warranty responsibility, upgrade paths, and emissions retrofits. The design endured, but the ecosystem around it became unstable. What makes this case particularly instructive is that the engine never failed in the way corporations typically fear. There was no scandal, no catastrophic defect, no dramatic loss of confidence. Instead, the engine succeeded so completely that it outlived the company that made it, exposing how little corporate survival depends on engineering excellence alone. Sulzer's collapse was not caused by the RTA engines. It happened despite them. The engines represented everything the company still did well: precision, restraint, long-term thinking. The corporation, meanwhile, moved in the opposite direction, toward short-term financial maneuvering, fragmentation, and strategic dilution. In the end, the RTA engines became survivors of a financial train wreck they did not cause. They continued powering ships long after executive strategies failed, balance sheets collapsed, and corporate identities dissolved. The lesson is uncomfortable but clear. Engineering excellence can preserve machines, but it cannot save companies unwilling to align their finances, strategy, and identity with the products that actually work. When accountants lost control of an unbreakable design, some engines fail because their designers compromise too much. Others survive precisely because their designers refuse to. In rare cases, that refusal creates a different kind of conflict, one where the engine becomes unmanageable, not technically but financially. This is the point where accountants lose control of a design that engineering refuses to weaken. Few stories illustrate this tension more clearly than the fate of the Napier Deltic engine and the collapse of the industrial structures meant to profit from it. The Deltic was not a conventional engine. Developed in Britain during the post-war period, it used a triangular layout with 3 crankshafts and opposed pistons. The configuration delivered extraordinary power-to-weight ratios, high rotational stability, and remarkable durability when properly maintained. In naval and rail applications, the Deltic proved capable of sustained high output that conventional diesels of the era could not match. From a pure engineering standpoint, it was a triumph. From a financial standpoint, it was a nightmare. The engine's complexity demanded extreme precision in manufacturing. Tolerances were unforgiving. Assembly required highly skilled labor, specialized tooling, and extensive quality control. These requirements drove production costs far beyond what accountants were comfortable defending, especially as global competition intensified and margins narrowed. The engine worked exceptionally well, but it was expensive to build, expensive to service, and resistant to cost reduction. That resistance became the core conflict. Accountants pushed for simplification. Engineers resisted. Attempts to reduce machining steps or substitute materials were met with warnings that performance margins would collapse. The Deltic's reliability was not accidental. It was the result of deliberate over-engineering. Remove that, engineers argued, and the engine would lose the very qualities customers depended on. This standoff hardened positions on both sides. Meanwhile, customers complicated the equation further. Naval forces and rail operators valued the Deltic precisely because it was unbreakable under stress. High-speed patrol boats and express locomotives relied on its compact power and endurance. These buyers were willing to tolerate higher costs, but only as long as support, spares, and institutional expertise remained intact. That support required sustained investment the corporate structure struggled to justify. As ownership and management structures shifted, the financial pressure increased. The companies responsible for the Deltic were reorganized, merged, or absorbed into larger industrial groups with different priorities. In these new environments, the engine was judged not by performance, but by spreadsheets. It was profitable on paper only if stripped of its complexity, something it fundamentally could not survive. Attempts were made to commercialize the design more aggressively. Broader civilian adoption was explored. Variants were proposed. None resolved the underlying issue. The Deltic was optimized for performance, not scale. It excelled in specialized roles but resisted mass market economics. Every unit built demanded the same intensity of labor and oversight. Eventually, financial control slipped. Rather than mastering the costs, management began isolating the engine program. Production volumes declined, investment slowed. Skilled workers were reassigned or lost. The engine itself did not fail, but the ecosystem that sustained it began to fracture. Documentation aged. Tooling was retired. Institutional memory eroded. Accountants achieved cost control not by fixing the problem, but by shrinking it. The irony was stark. The Deltic engines already in service continued to perform. Some ran for decades, rebuilt and overhauled repeatedly by operators who understood their value. Independent specialists emerged to fill support gaps left by corporate withdrawal. In practice, the engine outlived the organizational willingness to manage it. Conflict followed quietly. Disputes arose over spare parts, pricing, licensing rights, and responsibility for long-term support. Operators accused manufacturers of abandoning a design that still delivered unmatched performance. Manufacturers countered that maintaining such a complex engine no longer made economic sense. Both were correct and incompatible. What ultimately doomed the corporate side was not the engine's flaws, but its refusal to bend. The Deltic could not be cheaply simplified without losing its identity. It could not be easily automated without losing quality. It could not be outsourced without risking inconsistency. In a business environment increasingly driven by cost optimization, that rigidity was fatal. When the companies behind the engine receded, the design remained. Engines continued operating long after production ceased. The accountants regained control of balance sheets, but lost control of the narrative. The machine became proof that financial logic does not always align with engineering reality. The Deltic's survival exposed a hard truth. An unbreakable design can become uncontrollable when its value cannot be reduced to margins and efficiencies. When that happens, companies may choose survival over stewardship, leaving the engine to outlast the very systems that failed to contain it. The engine customers trusted while the company imploded. By the early 1950s, Fairbanks Morse stood at a crossroads few outside the industry fully recognized. Founded in the 19th century and long respected for precision machinery, the company had become a critical supplier of large diesel engines for naval, industrial, and stationary power applications. At the center of that reputation was the Fairbanks Morse opposed piston diesel engine, a design refined during World War II and standardized for U.S. Navy use between 1941 and 1945. The engine's credentials were not theoretical. During World War II, Fairbanks Morse opposed piston engines powered submarines, landing craft, and auxiliary vessels across both the Atlantic and Pacific theaters. After the war, thousands of these engines remained in service. From 1946 to 1955, the U.S. Navy continued ordering spare parts, overhauls, and technical support, treating the engines as long-term assets rather than disposable wartime equipment. Civilian customers followed a similar path. By the late 1950s, Fairbanks Morse engines were widely installed in power plants, pipelines, and industrial facilities where continuous operation mattered more than modern packaging. Operators trusted the design because it delivered predictable output, tolerated abuse, and could be rebuilt repeatedly without compromising its core structure. Engines installed in the early 1950s were still operating reliably well into the 1970s. The company behind them, however, was beginning to fracture. Between 1958 and 1964, Fairbanks Morse underwent repeated corporate restructuring as competition intensified and management struggled to balance diverse product lines. Rail equipment divisions posted losses. Industrial machinery margins tightened, and capital was increasingly diverted away from long-cycle engine programs toward short-term financial survival. The opposed piston diesel remained profitable, but it required specialized manufacturing and long-term support, exactly what financial managers were trying to scale back. The tension became visible in the 1960s. In 1963, Fairbanks Morse was acquired by Colt Industries, a move intended to stabilize finances and impose tighter cost controls. From a corporate standpoint, the engine division was now judged primarily by return on investment rather than field performance. Production volumes remained steady but limited. The engine sold reliably to conservative buyers, yet it did not fit strategies focused on rapid growth or diversification. Customers noticed the shift before executives openly acknowledged it. Between 1967 and 1970, operators reported growing delays in parts delivery and uncertainty about long-term factory support. Navy depots began expanding in-house overhaul capability to reduce dependence on the manufacturer. Power utilities quietly stockpiled components. These actions did not reflect declining confidence in the engine itself, but declining confidence in the stability of the company supporting it. The engine continued to earn trust even as its maker weakened. During the energy crises of 1973 and 1979, Fairbanks Morse opposed piston engines proved especially valuable. Their fuel flexibility and steady efficiency made them dependable backup and baseload units at a time when newer, more sensitive systems struggled. Customers leaned on engines installed decades earlier, while Fairbanks Morse itself faced shrinking relevance in a consolidating industrial market. Corporate unraveling accelerated in the late 1970s. Colt Industries gradually dismantled Fairbanks Morse's traditional structure, selling or spinning off divisions that no longer aligned with strategic priorities. By 1980, Fairbanks Morse no longer existed as a unified industrial giant. The engine business survived only in fragments, absorbed into successor organizations with narrower mandates. What did not disappear was the installed base. Engines built from the 1940s through the 1960s continued operating through the 1980s and 1990s. Independent service firms emerged to support them. Technical manuals were copied, revised, and circulated outside official channels. In some cases, operators reverse-engineered components because original suppliers no longer existed. The engine's reputation remained intact even as its corporate parent faded from prominence. Conflicts followed quietly. Customers argued that the engines had outlived contractual support obligations because the original manufacturer no longer existed in recognizable form. Ownership groups debated licensing rights, intellectual property, and responsibility for documentation. Courts became involved sporadically, not over failures, but over stewardship of a design that refused to retire. By the early 2000s, Fairbanks Morse engines built more than half a century earlier were still powering facilities in North America, Asia, and the Middle East. The company name survived only through successor entities and licensing arrangements. Trust in the engine proved far more durable than trust in the corporation behind it. The collapse was not sudden. It unfolded through mergers, divestments, and financial recalculations from the 1960s to the 1980s. Throughout that period, the engine did exactly what it had always done: run reliably, predictably, and without drama. That contrast defined the story. Customers did not abandon the engine when the company weakened. They abandoned the company while keeping the engine. In doing so, they revealed a distinction the industry often overlooks. Engineering earns trust through performance, but corporations lose it through decisions. Management failure versus mechanical reality. By the late 1960s, a widening gap had emerged in the heavy engine industry, one that had little to do with metallurgy or combustion efficiency and everything to do with governance. Engines that had proven themselves in war, infrastructure, and continuous industrial service were still performing as designed, while the companies responsible for them were unraveling under managerial pressure. This conflict between mechanical reality and management decision-making became increasingly visible between 1965 and 1985, as corporate priorities shifted away from long-term stewardship. The mechanical reality was straightforward. Engines, such as the Fairbanks Morse opposed piston diesel, Alco's 251 series, and several heavy marine and stationary power units built in the 1940s and 1950s were designed around endurance rather than optimization. They tolerated wide fuel variations, ran at conservative operating speeds, and were built to be rebuilt indefinitely. By the mid-1960s, many of these engines had already accumulated decades of service hours without fundamental redesign. Management reality was far less stable. Between 1965 and 1975, much of American heavy industry underwent consolidation, diversification, or acquisition. Executives increasingly prioritized quarterly performance, cost-cutting, and portfolio reshaping over long-cycle product support. Engine divisions, which required specialized labor, dedicated tooling, and long-term parts commitments, were viewed as capital-intensive liabilities rather than strategic anchors. This divergence became explicit in corporate restructuring decisions. When Fairbanks Morse was absorbed by Colt Industries in 1963, the engine division was evaluated primarily on financial metrics rather than operational performance. Similar patterns appeared elsewhere. Alco's engine business was repeatedly sold and reorganized between 1964 and 1977, despite its engines remaining in widespread railroad and marine use. In each case, management treated durability as a sunk cost rather than a competitive advantage. Mechanical data told a different story. Field reports from utilities, rail operators, and naval depots throughout the late 1960s and 1970s consistently showed that these engines were meeting or exceeding expected service life. Navy maintenance records from 1968 to 1978 documented opposed piston engines completing scheduled overhauls and returning to service with minimal loss in output. Power plants continued running engines installed in the 1950s with predictable fuel consumption and uptime. The machines were not the problem. Management responses often compounded the conflict. Rather than invest in modernizing support infrastructure, companies reduced parts inventories, reassigned experienced engineers, and shortened documentation programs. Decisions made between 1970 and 1980 to rationalize product lines frequently ignored the installed base. Customers who depended on engines for baseload power or mission-critical applications suddenly faced uncertainty, not because the engines were failing, but because the corporate entities behind them were retreating. This produced a paradox. The more reliable the engine, the easier it was for management to deprioritize it. Machines that did not generate frequent warranty claims or urgent redesigns were treated as low-risk areas for cost reduction. Support erosion was gradual and often invisible at the executive level, even as customers began preparing contingency plans. Conflicts surfaced in formal settings. Between 1975 and 1985, disputes arose over spare parts, pricing, intellectual property ownership, and responsibility for long-term documentation. In several cases, successor companies argued that legacy engines were obsolete, despite ongoing operation. Customers countered with performance data showing engines meeting contractual requirements decades after installation. Courts and arbitration panels were occasionally involved, not to address mechanical defects, but to determine who was obligated to support machines that refused to wear out. Meanwhile, independent realities emerged. By the late 1970s, third-party service providers began filling gaps left by retreating manufacturers. Former factory engineers established independent overhaul shops. Operators shared technical manuals and reverse-engineered components. These actions were not driven by nostalgia, but necessity. The engine still worked. Management structures no longer did. The contrast sharpened during external shocks. The energy crises of 1973 and 1979 exposed weaknesses in newer, more optimized systems, while older heavy engines continued operating with minimal disruption. Customers noticed. Trust shifted decisively toward the machine itself rather than the brand name attached to it. Purchasing decisions in the early 1980s increasingly emphasized proven designs and life cycle predictability over corporate promises. By the mid-1980s, the outcome was clear. Mechanical reality had prevailed operationally, but management failure had reshaped the industry. Companies that once built indestructible engines no longer existed in recognizable form. The engines, however, remained in service. Quiet evidence that engineering success does not guarantee corporate survival. This period demonstrated a fundamental imbalance. Management decisions are reversible only in theory. Mechanical designs, once deployed at scale, create obligations that outlast balance sheets. When leadership prioritizes short-term financial clarity over long-term responsibility, it is not the machine that fails first. In the end, the engines kept running. The companies did not, and that distinction defined an era where mechanical truth exposed managerial limits more clearly than any failure analysis ever could. Strikes, debt, and an engine that refused to quit. Between the late 1960s and early 1980s, Fairbanks Morse became a case study in how labor conflict and financial strain can dismantle a company even while its core product continues to perform flawlessly. The opposed piston diesel engine, by then already proven in war, industry, and power generation, did not fail during this period. The institution surrounding it did. Labor unrest marked the first visible fracture. From 1967 to 1973, Fairbanks Morse facilities experienced repeated labor disputes as unions pushed back against wage freezes, workforce reductions, and shifting production priorities. Skilled machinists and assembly workers, many trained specifically for opposed piston engine manufacturing, were laid off or reassigned. These were not interchangeable roles. The engine required precision assembly and deep institutional knowledge. Each strike and workforce disruption weakened production continuity without affecting the engines already in service. At the same time, debt pressure mounted. By the early 1970s, Fairbanks Morse was carrying obligations tied to underperforming divisions, particularly rail equipment and diversified industrial machinery. Internal financial reports from 1970 to 1975 increasingly treated the engine division as a cash reservoir rather than a strategic asset. Profits generated by long-term engine service contracts were redirected to offset losses elsewhere. Investment in tooling, documentation, and future engine development stalled. The contradiction was stark. From 1968 to 1976, U.S. Navy maintenance records continued to show Fairbanks Morse opposed piston engines, completing scheduled overhauls and returning to service with consistent output and fuel efficiency. Civilian power plants reported similar results. Engines installed in the 1950s were still meeting performance benchmarks 2 decades later. Operational reality and corporate health were moving in opposite directions. Strikes intensified the strain. In 1974, amid broader industrial unrest across the United States, Fairbanks Morse faced prolonged labor actions that further disrupted manufacturing schedules. Replacement workers lacked the specialized experience required for engine assembly, increasing internal rework costs. Management responded by reducing production commitments rather than resolving structural issues. This decision preserved short-term cash flow but accelerated long-term erosion. Debt amplified every misstep. By 1976 to 1978, interest obligations constrained flexibility. Management deferred modernization of engine production facilities and delayed parts manufacturing runs, assuming existing inventories were sufficient. Customers began noticing gaps. Utilities and pipeline operators reported longer lead times for components. The engine still ran, but confidence in corporate support weakened. The energy crises of 1973 and 1979 exposed the irony. As fuel prices spiked and power reliability became critical, Fairbanks Morse opposed piston engines proved exceptionally valuable. Their fuel tolerance and steady operation made them dependable baseload and backup units. Customers relied on machines built decades earlier, while a company that made them struggled to meet payroll and service commitments. Corporate fragmentation followed. Through the late 1970s, ownership structures shifted as Fairbanks Morse divisions were sold, absorbed, or restructured under Colt Industries. Each transaction added uncertainty about responsibility for long-term engine support. Contracts signed in the 1950s and 1960s assumed continuity that no longer existed. Customers were forced to plan independently. By 1980, the company was no longer functioning as an integrated manufacturer. Engine production slowed dramatically. Skilled workers had departed. Documentation programs lapsed, yet engines in the field continued operating. From 1980 to 1990, independent overhaul shops, often staffed by former Fairbanks Morse employees, emerged to fill the void. Operators pooled technical manuals, fabricated parts, and preserved the engines through collective effort rather than corporate backing. Conflicts surfaced quietly but persistently. Customers disputed parts, pricing, and licensing rights with successor entities. Some argued that the engine's continued operation created implicit obligations that ownership transfers could not erase. Legal disputes focused not on failure, but on abandonment. The engine's durability complicated corporate exit strategies. What made this period remarkable was endurance without advocacy. The opposed piston engine did not benefit from modernization programs or marketing support. It survived because its original design margins were generous enough to absorb decades of neglect. Mechanical reality resisted economic collapse. By the mid-1980s, Fairbanks Morse as an industrial force had effectively dissolved. Labor conflicts had fragmented expertise. Debt had hollowed investment. Management decisions prioritized survival over stewardship. Yet engines built between the 1940s and 1960s continued powering facilities across North America, Asia, and the Middle East. The story was no longer about innovation or growth. It was about refusal. Refusal of a machine to align its lifespan with corporate failure. Strikes weakened factories. Debt dismantled balance sheets. Ownership structures dissolved. The engine ignored all of it. In the end, Fairbanks Morse did not lose credibility because its engines failed. It lost credibility because the institution could not withstand pressure that the machine had already been designed to endure. The engine refused to quit. The company could not. Abandoned by its maker, kept alive by the industry. By the early 1980s, the separation between Fairbanks Morse as a corporation and the engines bearing its name had become unmistakable. The opposed piston diesel, introduced into large-scale service during World War II and refined through the 1940s and 1950s, was still operating reliably across naval, industrial, and utility installations. The company that designed it, however, was no longer positioned to support it in any meaningful way. The turning point came between 1978 and 1981, as Colt Industries accelerated the breakup and divestment of Fairbanks Morse divisions. Responsibility for long-term engine support became increasingly ambiguous. Engine production slowed, then largely ceased. Internal engineering teams were dissolved or reassigned. Formal parts manufacturing schedules were reduced. By 1980, customers seeking clarity on future support were receiving inconsistent answers, or none at all. The abandonment was administrative, not technical. U.S. Navy records from 1980 to 1986 show that Fairbanks Morse opposed piston engines continued completing scheduled depot overhauls with predictable performance. Power utilities operating engines installed between 1948 and 1962 reported stable output and fuel efficiency through the early 1980s. Pipelines and industrial plants treated the engines as fixed infrastructure, budgeting for rebuilds rather than replacement. Operationally, nothing had changed. Institutionally, everything had. By 1982, the industry began responding independently. Former Fairbanks Morse engineers and machinists, many displaced during layoffs in the late 1970s, formed independent service companies across the United States. These firms specialized in overhaul, component refurbishment, and field support for opposed piston engines. Without access to official factory backing, they relied on accumulated experience, archived drawings, and reverse engineering. In practice, they recreated a support ecosystem the manufacturer had abandoned. Events accelerated this transition. In 1983, several utilities reported multi-month delays in obtaining factory-authorized replacement components. Rather than wait, operators commissioned third-party fabrication of liners, pistons, and bearings. By 1984, informal parts networks were operating across North America, sharing specifications and tolerances. What had once been proprietary knowledge became communal necessity. Conflicts followed. Successor ownership entities disputed the legality of third-party manufacturing, citing intellectual property rights inherited through corporate restructuring. Operators countered that the original manufacturer no longer fulfilled contractual support obligations established decades earlier. Legal disputes emerged sporadically between 1983 and 1989, not over defective engines but over who had the right or duty to keep them running. Courts were asked to interpret responsibility in cases where the product outlived its maker. Internationally, similar patterns emerged. In the Middle East and Southeast Asia, Fairbanks Morse engines installed during post-war infrastructure expansion remained critical to power generation. By the mid-1980s, regional service hubs had formed, often staffed by technicians trained in the 1960s and 1970s. These hubs maintained engines using locally fabricated components, adapting designs to available materials while preserving core geometry. The irony was persistent. The engine's durability enabled abandonment. Because opposed piston engines rarely failed catastrophically, the lack of manufacturer support did not immediately force replacement. Management decisions made between 1975 and 1980 assumed engines would age out naturally. Instead, they endured. Every year, the engines continued running undermined arguments that the design was obsolete or uneconomical. By 1990, the ecosystem sustaining the engine was almost entirely external. Documentation circulated as photocopies and scanned manuals. Training occurred through apprenticeship rather than factory programs. Spare parts were produced in small batches by specialist firms. The engine had become an industry-maintained artifact rather than a corporate product. Events in the 1990s reinforced this reality. As deregulation reshaped power markets, operators sought dependable assets with known behavior. Engines installed 40 years earlier offered predictable performance in an uncertain regulatory environment. Replacement was riskier than continuation. The absence of manufacturer backing became an accepted condition rather than a crisis. The final separation was cultural. By the early 2000s, Fairbanks Morse existed only through successor names and licensing arrangements. The opposed piston engine, however, remained identifiable, serviceable, and trusted. Operators no longer associated it with corporate identity. They associated it with uptime. The engine was not preserved out of sentiment. It was preserved because it worked, and because the industry chose stewardship over replacement when the manufacturer withdrew. That choice created a rare outcome in heavy machinery history, a product sustained not by corporate continuity, but by collective reliance. Abandonment did not kill the engine. It transferred ownership of responsibility from boardrooms to workshops. In doing so, it proved that when a machine earns trust deeply enough, an industry will refuse to let it die, even after its maker walks away. How a perfect engine couldn't save a broken company. By the mid-1960s, Fairbanks Morse possessed something most industrial firms spent decades chasing: a mature, trusted, and technically proven engine with a global installed base. The opposed piston diesel, standardized during World War II between 1941 and 1945, continued delivering reliable service in naval vessels, power stations, pipelines, and industrial facilities. By any mechanical measure, the engine was a success. Yet, between 1965 and 1985, the company that built it steadily unraveled. The contradiction exposed a reality the industry often avoids. Engineering excellence cannot compensate for institutional failure. The engine's performance record was beyond dispute. U.S. Navy maintenance data from 1960 to 1975 showed opposed piston engines repeatedly completing scheduled depot overhauls and returning to service with minimal degradation in output. Civilian utilities reported similar outcomes. Engines installed in the late 1940s routinely logged uninterrupted service into the 1970s. The design's conservative operating speeds, generous material margins, and rebuild-friendly architecture delivered exactly what it promised: longevity. Corporate reality moved in the opposite direction. Between 1958 and 1964, Fairbanks Morse struggled to manage an increasingly fragmented portfolio. Rail equipment divisions underperformed. Industrial machinery margins tightened. Rather than consolidate around its most defensible product, the engine, the company attempted to sustain multiple capital-intensive lines simultaneously. This dilution weakened cash flow and decision-making long before the engine business itself faltered. A pivotal event occurred in 1963, when Fairbanks Morse was acquired by Colt Industries. The acquisition was intended to stabilize finances and impose tighter managerial discipline. In practice, it shifted priorities. Long-cycle businesses like heavy engines were evaluated against short-term financial benchmarks they were never designed to meet. The engine division remained profitable, but it required skilled labor, dedicated tooling, and decades-long support commitments. Those requirements conflicted with corporate strategies focused on flexibility and cost compression. By the late 1960s, warning signs were visible. From 1967 to 1970, customers reported slower response times for parts and technical support. Navy depots expanded in-house overhaul capability to hedge against uncertainty. Utilities began increasing spare inventories rather than relying on factory supply. None of these actions reflected doubts about engine reliability. They reflected doubts about corporate continuity. External shocks deepened the divide. The energy crisis of 1973 elevated the value of dependable, fuel-tolerant engines. Fairbanks Morse opposed piston units performed exactly as intended, providing steady baseload and backup power when newer systems struggled. Ironically, this operational success masked corporate weakness. Because engines kept running, management delayed decisive restructuring of support infrastructure. Labor conflict added strain. Between 1967 and 1974, Fairbanks Morse facilities experienced repeated labor disputes, including strikes that disrupted production and accelerated the loss of skilled machinists. These workers carried institutional knowledge critical to engine manufacturing and overhaul. Their departure weakened the company's ability to sustain the product, not because the design changed, but because expertise evaporated. Debt pressure compounded every issue. From 1970 to 1978, profits generated by engine service contracts were increasingly diverted to offset losses in other divisions. Investment in modernization stalled. Documentation programs aged. Tooling upgrades were deferred. The engine remained mechanically sound, but the organization supporting it hollowed out. By the late 1970s, corporate fragmentation became irreversible. Colt Industries began divesting Fairbanks Morse divisions that no longer aligned with strategic goals. By 1980, Fairbanks Morse ceased functioning as a unified manufacturer. Responsibility for the engine program was split among successor entities with limited mandates. Long-term stewardship, assumed in contracts written decades earlier, was no longer clearly owned. The result was a structural failure, not a technical one. Engines built between the 1940s and 1960s continued operating into the 1980s and 1990s. Independent overhaul firms, often founded by former Fairbanks Morse engineers, emerged to fill the support vacuum. Operators reverse-engineered components, shared manuals, and maintained engines through collective effort. The machine survived because it had been designed to survive neglect. Conflicts followed quietly. Customers disputed parts, pricing, licensing rights, and support obligations with successor organizations. Courts were occasionally asked to determine responsibility, not for engine failures but for abandonment. The engine's endurance complicated corporate exit strategies, refusing to align its lifespan with financial collapse. By the early 2000s, the conclusion was unavoidable. Fairbanks Morse as an institution had failed to adapt to changing economic realities, despite owning one of the most durable diesel designs of the 20th century. The engine could not save the company because the company's problems were not mechanical. They were managerial, financial, and strategic. The lesson was stark. A perfect engine can deliver decades of trust in the field, but it cannot repair fragmented leadership, misallocated capital, or eroded accountability. Engineering excellence creates opportunity. Only governance determines whether that opportunity survives.